Hello guys, welcome you all. In this video, we're gonna see how this program gets executed inside the CPU. We are basically gonna see a deep dive into the execution of this program. Um, let's start. This is a basic C program and the pseudocode. It's actually a pseudocode. You can see here program execution starts from here void main, and there are static variables. Let's say int a, b, c, and there is one instruction. C is equal to a plus b, and then it's printed. The C value of the C is printed. Okay, I've written this program, and then you have given this program to then you have saved this program actually as sum. Let's say your name of the program is sum.c, and this saved program follow my pointers for this approach. Okay, so name of the program is sum.c. You have saved inside the hard disk. Okay, and this hard disk and this program you're compiling now. The program will be compiled. You'll give to a compiler. Compiler basically converts high level language into a low level language. High level language is C language, where we basically write our programs, and low level language is machine understandable language. It is in the terms of zeros and ones. Okay, and this sum.c, as soon as it is given to the compiler, it will be converted into a file called a.out. This is an executable file which compiler generates, this a.out file. Okay, this is a part of actually there are 7 phases inside the compiler. We'll see that in a different video. It's a part of a compiler. And then this program is actually saved inside a hard disk. This program is brought to the main memory, that is primary memory RAM. In this video I'll be referring primary memory for RAM and secondary memory as a hard disk. Okay, this program from the hard disk is brought to the primary memory by the operating system. This is the work of an operating system to bring this program from the hard disk to the primary memory. As soon as it comes to the primary memory, it becomes the process. Okay, OS brings the program from the hard disk and puts it into the data structure called process. Actually, process and a type of a data structure where the OS converts this program into something known as you can see in this diagram. The first is a.out part, where this is executable file, as just now I told you. And the second is global and static variables, and the next part is a code part where c equal to a plus b is stored. And then we have two sections called heap and stack area, where heap area is growing upwards and stack area is growing down. We don't have a clear distinction between heap and stack. This can be altered or changed. For an example, we write two subjects in a similar book. From the first page we start one subject, and from the last page we start another subject. We don't know where both the subject ends. So right, that's a reason, right? So yeah, in the same way, we don't have clear distinction between heap and stack area. Heap grows upwards and stack grows downwards. Similarly, when they meet, they stop. This is all about the process. Okay, the main difference between a program and a process is program can be divided into multiple programs, where program cannot be divided, where a process can be divided with the help of threads. These are also called as multi-threaded process and single-threaded process. We'll see that in a different session. As of now, let's concentrate on this. Okay, each process has a process control block. This is where I've showed you this PCB, this process control block. Each let's say, like, for all the process we'll have separate process control blocks. Let's say we all have other cards, identity cards, right? In the same way, like, each process will have its own process control block, and there are many attributes inside process control block. Let's say some of them are PID, P state, like priority. These are all the attributes of process. Okay, in the same way, we have different PCBs for different processes. They're all connected in the manner of a linked list. They're all connected through a linked list. So this is all about the process and its process control block for this particular program. And we'll see, this is all the part of process management inside OS. It comes in operating systems of process management. Now let's switch on to how exactly the CPU executes the instruction. This is known as instruction cycle. It comes in computer organization and architecture subject. Okay, in the same, I've shown you the process diagram here. This code part represents this instruction section in the main memory, and this global and static variables represent data section. Actually, main memory is divided into two, that is code section and data section. Let me show you one second. This is a data section and this is a code section. Main memory is divided into two. It's a code section and data section. They are separately connected to a CPU, independently connected to a CPU. Actually, every devices are connected to each other through buses. These are also called as there are three types of buses: address bus, data bus, and control bus. Uh, okay, we'll see to that later. Okay, let's say we assume we have nothing here. Let's say this PC is an actually a program counter. It's a type of special purpose registers. Where registers we have two types of registers: special purpose registers and general purpose registers. Program counter is a type of a special purpose register. Let's say we don't have anything here, we'll somehow bring the 200. The 200 is the address of that particular instruction which we wanted to execute. Let's say program counter has 200, and that address from this that it'll it'll go to that particular address, and from that address it will fetch this instruction I1. Okay, through read this instruction I1. Okay, instruction I1 will be fetched from the main memory and brought to the CPU, because all the executions will run on the CPU. CPU has two parts: control unit and ALU, arithmetic logic unit, where all the operations will take place inside the ALU. So this particular instruction will be brought from the main memory to the CPU through address bus. Okay, address bus is unidirectional. Only one way, only in the one direction, where CPU can send the signal towards the main memory. Okay, and it will be this instruction will be brought to the CPU through data bus. Actually, data bus is multi-directional. Both main memory can send data to CPU and CPU can send data to main memory also. As soon address is actually basically divided into three parts. Instruction is basically divided into three parts: opcode and address 1 and address 2. Opcode is generally operation to be performed. In our case, it is addition of two numbers. And addresses are generally operations, operands. This is address 1 and address 2, because we have two operands in our code, that is a equal a plus b equal to c. And this is a address. We'll decode. The first process is decoding all these instructions. If we decode opcode, we'll get operation as plus, and if we decode this address 1 and address 2, we'll get effective address of 500. This then CPU will go in search of 500 inside the main memory. Inside the 500, we have this operand a. We'll fetch this operand and we'll bring it to a register. Say it's a data register. Every value which comes from a data bus is stored inside a data register. Let's say R1 and R2 are two data registers, and value of A is brought back to R1 register, and value of B is brought to data register R2, and then they are sent to an ALU, that is arithmetic logic unit, and where our main code will get summed up and the resultant will be produced, and that resultant will be stored in AC. AC is an accumulator. Accumulator is also a type of a special purpose register, where it will store the data, which is it will store the some result data, and that result data will be returned back to our resultant variable C. That is, C is our resultant variable. Through this system calls, it will be written back to the C. This is how the program gets executed inside the C. This is the instruction cycle. This is a topic of computer organization and architecture. You can also map this topic to process a state or process life cycle in operating systems. I'll tell you how. Okay, in the beginning, when the program is saved, the process is a new state, which is in secondary memory, that is in hard disk. As soon as a program comes inside the RAM, that is a primary memory, it gets converted into ready state. Okay, every process which are in ready state are inside the RAM, basically inside the primary memory. Every process which are inside the primary memory are in ready state. Okay, the process, it's a work of an operating system schedules the task by some CPU scheduling algorithms and selects that particular process, and that particular process selected will be given to the CPU for its execution. Like this, it'll move to running state. All the process which gets executed inside the CPU are in the will be in the running state. That is also in the primary running state basically. And when the program gets executed, it'll complete its execution and terminate the termination state. That is the final state of an process. Yeah, the execution of the program ends there. So yeah, that's it. Yeah, so that's all for this video.